try for my u here. Let's let u be 1 minus x squared. That's something that's definitely on an inside. What's du going to be if u is 1 minus x squared? It's going to be minus 2x dx. Okay, so here's a place where I don't have an x cubed, or I have an x cubed. It doesn't look just like an x. To make it look more like that, I'll rewrite x cubed as x squared times x times cube root 1 minus x squared dx. Okay, now I still wish I had a negative 2. I'll multiply by negative 2 here and multiply by negative 1/2 outside to cancel that. And now this and this all make du. This part becomes cube root of that thing is u. I still have this pesky x squared I need to deal with, though. What can I do with x squared? I can take this. I don't need to solve all the way for x, because I've got an x squared there. If I add x squared to both sides, u plus x squared is 1. So x squared equals 1 minus u. Now I have a formula I can use to change an x squared. X squared becomes 1 minus u. It needs parentheses because it's all being multiplied by that cube root u. So I got negative 1/2 integral of 1 minus u times cube root of u means u to the 1/3. Don't try and integrate this separately. The product rule doesn't work like that. This is not a hard problem because I can distribute the u to the 1/3 into there. Get negative 1/2 integral of u to the 1/3 minus 1 plus 1/3 is u to the 4/3. And now this is something I can do with the power rule. I got negative 1/2. 1/3 plus 1 is 4/3. Divide by that out front, get 3/4. 4/3 plus 1 is 7/3. Divide by that, get 3/7 out front. Plus c. I should probably distribute the 1/2 into here. And I also need to say what u was. U was 1 minus x squared. I'll do both of those in one step. Negative 1/2 times 3/4 is negative 3/8. Stuff to the 4/3 where my stuff was 1 minus x squared. Negative 1/2 times negative 3/7 makes positive 3/14. Stuff to the 7/3 where the stuff is still 1 minus x squared. Plus c. I think this is right. We got a bounded integral. We'll do the substitution u equals 1 minus e to the x. It's a thing I see on the inside whose derivative is almost e to the x is outside. Du will then be, what's the derivative of this? Negative e to the x dx. I wish I had a negative. I'll put a negative here and a negative here. And now this, and this join forces like Voltron to become just du. This thing is now u cubed. The negative out front is still out front. But key thing, I gotta change the bounds of integration. This is x equals 0 to 1. When I convert that to a u integral, what do my u's become? When x is 0, u is 1 minus e to the 0 is 0. Okay, that one didn't change. When x is 1, u is 1 minus e to the 1 is 1 minus e. So that's the one I want to do. I got negative. The integral of u to the 3rd is easy, 1/4 u to the 4. And now I need to evaluate that from 0 to 1 minus e. I got negative. Plug in 1 minus e, 1/4 1 minus e to the 4th. Minus plug in 0, 1/4 0 to the 4th. That one's 0. I got negative 1/4 1 minus e to the 4th. Cool. Be sure you don't put a plus c on these answers, because when it's a definite integral, your answer is a number. Saying a number plus a constant makes it every number, and it's not. The plus c would have cancelled. If you put the correct place to have put the plus c, you don't need it here. Would have been here. You have plus c minus plus the c's cancel, the c goes away. Let's do the u substitution. U equals x squared on this thing. We don't have to finish the integral. If x is u squared, I didn't mean for this to be the exact same as the other one. Maybe I probably mixed it up on the evens. If x is u squared, then dx is 2u du. Okay. This becomes the integral of x squared becomes u squared squared, that's u to the fourth. X is u squared, 1 minus x to the fourth is u squared to the fourth, that's u to the 8. Dx is 2u du, and I need to change the bounds of integration. This is x equals 1 to x equals 3. If x is 1, what's u? 1 equals u squared, 3 equals u squared. I get two answers. I'm in a weird situation where I can pick either of these. Let's make it from 1 to root 3 is the simplest choice. The answer will turn out to be the same no matter which of these choices you make, though. Kind of surprisingly. Cool. X cosine 4x, we're into integral by parts. We're going to pick u to be x because the derivative of it will go away. dv is everything else, cosine 4x dx. du is derivative of that dx is just 1 dx is dx. V is the integral of this. The integral of cosine is sine. The 4x is something I have to divide by. I got to divide by 4, so the derivative will not have the 4 that the chain rule wants to poop out. This is the baby substitution thing. It only works when there's a constant multiple of x. If it's an x squared or something, this trick doesn't work. Okay, integral by parts formula says the integral of u dv, which this is u dv, equals uv minus integral v du. So I get u v minus the integral of v du. I got 1/4 x sine 4x minus a fourth. What's the integral of sine? The integral of sine is negative cosine, and then gotta divide by that 4 again. A fourth of a fourth, I guess I should do that. A fourth times a fourth is 1/16. Cool. X cubed natural log x. I didn't go too far, did I? Cool. Again, it's by parts. We like letting u be powers of x, but we like letting u be a natural log even more. We love u as natural log, because the derivative of natural log gets rid of a natural log. Derivative of natural log is 1 over x dx. dv is everything that's not natural log, so that's x cubed and dx. So v is, integral of that is 1/4 x to the 4. We could put a plus c there, we usually don't want to. I want uv minus integral v du. uv is 1/4 x to the 4th natural log x, minus the integral of v, 1/4 x to the 4th, du is 1 over x dx. Don't try and integrate these separately. X to the 4th times 1 over x simplifies, is why this is productive. I get the integral of x cubed is what I'm left with when they cancel. The integral of x cubed is 1/4 x to the 4. A fourth of a fourth is still a 16th. This part's still here. Boom, we did it. Low on time.